See here what happened, they have given, let us solve another one example. In this example, what they have shown, they have shown one generator, two motors, M1 motor M1 and M2 is the motor, one transformer T1 and transformer T2 they have given. In this one what happened, motor 1 is grounded, motor 2 is not grounded, generator also is grounded. Now they have given the specification of the T1 and T2, and this T2 transformer, this is a single phase, the value or specification given for the this T2 transformer, it is of a single phase, they have given of a single phase, so we have to convert into three phase. So for this one I have made a diagram. You can see this is a diagram. In this diagram, particularly diagram, they have given all the specification, that is generator they have given as a 300 MVA, 20 kVA, 20 kVA generation it is producing, and reactance, sub transient reactance is 20%. This is a transformer, okay, this is a transformer, this is a transformer 1 and this is a transformer 2. Transformer 1, it is 350 MVA, 230 bar 20 kV, 10% reactance, subtransient reaction. And from here, from transformer 1 to the transformer 2, a transmission line is there, transmission line of a 64 kilometer. See this 64 kilometer transmission line they have given. And to this again what they have done, transmission line is given, the value of this one, it is given as a point 5, point 5 for this one. They have given the transmission series reactance, they have given as 0.5 ohms per kilometer, it is a per kilometer. So now T2 value they have given, that is T2 value is 100 MVA, 127 bar 13.2 kV, 10%. It is of single phase, it is for single phase, this is all single phase. So you have to convert for three phase, three phase you have to convert, we have to convert this. When we convert, it becomes 300 MVA, that is 100 into 3, into 3 when we multiply we get 300. And this also voltages we have to convert into three phase. Now voltages if you see, it is a producing, generator is producing 20 kVA, that is 20 kVA supplied. So this is 20 kVA, again this is 20 kVA by 230. So the it is stepping up the transformer, so this is 230, okay, 230, the whole transmission line is of 230 kVA, it is 230 kV, again 230, it is 230 is there. So this is for single phase, so we have to convert it to three phase, three phase we have to convert it. So it is step down to what, 13.2. So 13.2, two motors are operating at 13.2, that is M1 M2. Value of M1 is, value of M1 is 200 MVA, 20% subtransient reactance, 100 MVA, 20% subtransient reaction. So this is a diagram, we want to find the reactance. What we have to find, we have to find the reactance of this one. If you want to find the reactance of this one, reactance of this, let us see first. This is a generator, so what I'll do, I'll put the generator here, one transmit, one reactance, this is plus minus generator, okay, this is from here, again where it goes to the transformer, another one transformer, okay, this is what, T1, this is T1. Now from here it goes to the transmission line, full transmission line, so another reactance, this is TL, okay, TL. Now where next, next it goes to the transformer, it goes to the transformer, this is T2 transformer. Now here what happened, two motors are there, motor 1 and motor 2, so we have to take like this, common point is there. So what happened here, trans reactions, put the value, okay, there, again one motor M2 will be there, put this one again, now connect this one, okay, now connect to this one. So this is what, this is E1 EG generator, this is motor, this is EM1, EM2. Now we have to find the values, the values of this one, this one, this one, this one, this one. We have to find the values. Now let us find the solution for this one. So we'll find the solution, we find the values of all this one. Now this one, first what we'll do, we have to convert this one. We have to convert these values. This first, these values are in single phase. It is made up of a three phase. So they have given the value of a single phase. So we will find the three phase rating of transformer T2 is 100 is there. What is there? 100. So rating into 3 into 300 is equal to, that becomes 300 kVA. It is in 300 kVA. 300. Okay. This is, sorry, it is MVA. 300 MVA. We have to go for 300. And now line, we have to find line to line voltage also. Line to line voltage of this T2 transformer. So ratio transformer ratio, that is equal to root 3 into, we have to multiply this one, 127 upon 13.2, that we get as 220 divided upon bar 13.2 kV, that is the kV. This is, we can see here, we can see this here. Now we, what they have told, they have told to select the generator as the base, generator as a base. So select, they are told select generator rating as base value. So the 300 is base value. Okay, 300, whatever 300 value we are getting, MVA, that is all base value. We have to apply for whole system. We have to take it for the whole system, this one. So now in transmission line, what is the transmission line? Transmission line, it is of 230, complete 230 kV. This is 230 transmission line. It is 230 kV. Okay, this value 230 is there, so it becomes 230, complete 230 becomes. Motor, now motor, we have to consider the motor. For motor circuit, what is the output? Okay, what is the output? Here they have shown 13.2, the value, the specification rating of this one is 13.2, but actually how much it is coming, we have to calculate that. So for that one, what will do? 230. What is the new value? New value, we have got, this is 230, 230 into divided by 220. What is the value we are getting? We are getting 220 value, 220 value upon 13.2. Okay, upon 13.2. So what we get? The new value, motor value, which is they are running, the new value, it is 13.8 kV. They are running at 13 point. See, this they have not given directly. If they had given directly, then we can use it directly, we can use in the formula and we can find. But he has given for the single phase, then again we have to convert for the three phase, then we have to get the this values. Now transformer, what we'll do now, we'll find out the per unit of the transformers. Okay, transformer 1, transformer T1 is good. This is, for this one we have a formula. Okay, you have a formula, that is transformer ZPU old, ZPU old value we have to take for this one, then multiply MVA. Okay, this MVA base new divided by MVA base old into kV base old divided by kV base new whole square. This is whole. This is very important formula. This is very important formula. Everywhere it is used. This formula, it is used everywhere. Base new, base old. Okay, base old are whatever the values are there, these are the old values. Whatever the value we got, these are the new values. It is called as a new values. Okay, now transformer, let us find for the transformer. Now we'll find out for a transformer. This is I'm finding out for a transformer, that is transformer T1. Okay, what is the value? What is the transformer value first? Reactance. This is the reactance. Z is the reactance. Okay, Z is the reactance. What is the reactance? 10%. 10% means 0.1. Okay, what is the new value? What is the new value? New value for this one is, already they have told to use 300. That is a new value. This is base new. We call it as a MVA base new. It is a new value. Okay, this is MVA base new value. So that one into will multiply with multiply what it is, 300. 300. What is the old value? MVA base old value, that is a transformer. This is the old value, 350 MVA is the old value. Take 350 MVA old value into what is the next? What is the next? This is KVA base old. Okay, KVA base old. What is the KVA base old? KVA base old is here values 13.2. Next, what is the new? What is the new value? New value is 13.8. Okay, the new value for this one is, see there was a confusion. Okay, we will start with once again with the transformer one. Okay, this is transmission of finding one transformer, that is Z. Already I told you it is 10%. Okay, 10%, that is 0.1. This one is new one is 300 already given. This is 350. Next, this is base. See, for a transformer 1 and 2, then transformer, if you see the transformer, there is no change. So for the transformer you can take any value, either you can take 20 or you can take 230 here, because directly they have given it is a 3-phase transformer. So for 3-phase transformer I will consider highest value. I will consider that is 230 upon 230, same value. Old and new are the same value for the transformer. This goes. So value for T1 is 0.0857 per unit. Now for transformer 2, let us take for transformer 2, same formula. What is the old? What is the old? They have given as, 0.1, 10%, that is 10%. Okay, 10% they have given 10%. The same value we have to here. What is the MVA base new? Base new they have given as a 300. What we got the value here? We got the value 300 only. 300. Now what happened here? Base KV base and base old and new changes. Here the value they have given old value as 13.2. New value what we have got? New value we have got 13.8. So this becomes square. Okay, this is a square. That is how much we are getting? 0.0915 pu. We got the value for this. So base impedance of transmission line T line is equal to, that is nothing but we know formula kV square upon kV, that is this one kV square upon kVA or MVA. So we have value. What is the value? It is a 230. It is a 230 kV. What is the kV? 230. 230 whole square divided by 300. It is a 300. We have to take 300 for it. So what is the value? We are going to get 176.3 ohms. Okay, but it is for it is for what happens here, we have to consider for 64. We have to consider for this one 64 kilometers. Okay, so reactance of the line, reactance of TL transmission line is 0.5. What is the value? The value is 0.5 per kilometer. So how many kilometers? 64 kilometer. 0.5 into 64 kilometer divided by this value, we get the 76.3. So what is the value again? 0.1815 pu per unit we are going to. Now reactance of motor M1. Okay, M1, it is same formula, we have to use the same formula. Okay, what formula we have used here? The same formula. What is the old one? What is the reactance of motor 1? That is 20%. So 0.2. What is the MVA base new? It is 300. For a, this is same base new, MVA base new is entirely it is same, because in question itself only they have told to select the generator base. So what is the generator base? That is 300. It is entirely same for all the system, 300. What is the old MVA base old? 200. It is 200. So next we have to take, what is the new one, what is the old one? Old one is, for this one is 13.2. 13.2. What new one, what we have found? 13.8 we have found. 13.8, this whole square. So we are getting 0.2745 pu we are getting. Now reactance again, reactance of motor M2, it is the same. What is the value? Here it is reactance, same, we have to use the same formula, this formula we have to use. What is the value? 20%. So it becomes 0.2. What is the new one? New one is 300. MVA new is 300. What is the old one? Old one is 100. Okay, 100 we have got. So next again same, it is operating on two different kVA. kVA old is what it is? kVA old 13.2, the value 31. New one what it is? 13.8. 13.8 we have found. This is square it, we get 0.5490. So now we will put all this value here. For generator we have to put all the values. What is generator? This already they have given generator, that is how much they have given in the generator they have given 20%. So it is J 0.2. Okay, T1 we have find out, we have found T1. This is the T1 we have found. So put this value, J is equal to 0.0857. What is the transmission line? Transmission line we have found, this is the transmission line. Okay, put the value, J is equal to 0.1815. Now transformer T2, okay, we have found transformer T2. Put the values, J is equal to 0.0915. For motors we have found, for motor 0.275, 0.5490. Put the values here. Okay, 0.02745 and G is equal to 0.540. So this is a diagram, reactance diagram what we have found out.